Hello, and now we're into, I think it is day 5 of Advent. So it's a bit of a late one today, but I am also joined by Phoebe.
Hello there.
And we're on to day 5. Day 5 is over here. Phoebe, you want to do the honours? A little bit bigger than yesterday's. And what have we got?
What's that?
We've got a bunch of wire. Well, I thought wire might come into it eventually.
Interesting.
It's all wrapped up. What it didn't come with was pliers. Luckily, I have some. So let's see what day 5 has to offer in the booklet. Day 5. Behind the 5th door, you'll find an integrated circuit. Ooh, hold on. You nearly missed this, Phoebe. Have a look.
I just picked out what was at the top.
Oh, I can't get it to focus on this. We might have to change the lighting. 1 minute. So, Phoebe, that's an integrated circuit.
Wow.
And it is
a LM386 audio amplifier.
So this audio amplifier basically will take an audio signal and make it louder for us.
Ooh.
So their speaker, they're going to make some circuit which is going to make some sound on the speaker louder. We touch a wire, so it's almost using this wire as, I guess you could say, as an amplifier. Now what's it going to say? So assemble the circuit, cut 3 lengths of 1 point. So we're going to need some wire cutting and stripping stuff.
Oh, well, let's go get that from the toolkit.
Good idea. Be right back. Okay, we have the tools. So we want 3 lengths of 1.5 centimeters each. Eyeballing it, that looks about 1.5 centimeters to me. Close enough.
Good enough.
I think we don't need to be overly precise with this.
I'm never precise with anything.
That. And we will do them roughly the same. Ooh, I'm going to put it this way round.
There we go. That's not bad.
Do the last one. You want to do that?
Sure.
Okay. Don't cut me.
No promises.
Oh, right. You got to cut where the actual blades are. Yeah, that's it.
There we go. Not bad.
Right, now it says completely remove the insulation, which, you know what? I probably should have done that before cutting it, but okay. And what they're doing here is making these jumpers. So I'm used to working with either pre-cut wire or just stripping off a bit of each. Have you ever seen... I've not got the stripper tool here. I've got the crimper tool. 1 minute.
These look like strawberry laces.
Okay, there's the actual wire strippers. These are fancy ones. That are these are the engineer ones, and I've got the expansion that allows me to control the length of what I'm stripping at, although in this case it's not really appropriate.
Those are so cool.
So what we can do is...
What are you doing?
Pop the wire in. And...
I have no idea what you're doing.
Well, you basically cut it in a circle. And then you pull it off, except I've not got pliers, which generally makes the job easier. Like that. You see? And although it said to strip all of it, I think we're going to have to strip enough to be able to get to all of it. There we go. We'll just do this along here a bit further along.
You probably should have done this before.
Well, if you buy this kit, this is what you're going to end up doing.
Sure.
And one problem is here is the kit. I don't know that it suggested no soldering, which it has kept to, but I'm not sure it said that you needed wire strippers. Let's have a look. Did it say about things you need? No soldering. Well, we'll get a 256-step sequencer. Well, we'll get to that later.
I don't know what that is.
But it says all the electronic components. It does not say anywhere that it would require things like pliers and a wire stripper. And I might have stripped it in too tight a strip because you've actually got a few kinks in that. Okay, no worries. The kinks aren't a big deal.
No biggie.
Right, well, let's use the next notch along. So I use the 30, we'll use the 28.
What's the difference?
Well, these are actually using an American wire gauge, although there's millimeters here as well. And as the American wire gauge goes down, it gets wider.
Oh, that's interesting.
So again, the way you do it is you put it between the notches,
And then you
grip
twist
it, you twist it around because you're basically cutting through the insulation, separating it from the other insulation.
And then popping it off.
You want to try?
Sure.
Okay. So got that in one hand, wire in the other.
What side? 28?
28 is good. Yeah, 28 is good because 30 was kinking the wire. There we go. Yep. Oh. Hold on. You got the wire on the line there. There you go. Okay, good. Now turn it round. Okay. See if you can go all the way around a little bit or closer to all the way around. It's kind of a bit tricky. And then, okay, and then let go. And
Not quite. Good enough.
you got some. Okay.
I tried.
Right. Chomp a bit more off here then. A bit closer. There we go. Yep, like that. We'll be back in a minute. We'll do all of them.
Right, now these are all done. They took not too long.
Bit kinked. I am going to use some pliers just to A, straighten them up, and B, to form them. Because again, this isn't something they talk about. So they just say cut them and completely remove the insulation. Right, the insulated wire at pin 3 needs to be about 3 centimeters long, remove about 5 millimeters of it. So let's get about 3 centimeters. So would you say that or that? There we go, about there.
I think that's good enough.
It's good enough. I mean, it's only really kind of an aerial, so it's about 3. It doesn't have to be. There we go. Right, we'll take off
It doesn't have
5 millimeters, not 5 centimeters. 5 millimeters off of each end.
Boop. There we go.
Pop that off. Now, when I'm actually being serious about this and doing proper boards, I can use this little doohickey here and actually measure out the length of them. But, you know, for this purpose, it's a bit overkill. So I don't think we need it. But what I will be doing is, because I know what these are going into, I'm going to try and form these up with pliers. So we kind of try and pre-form them like that. Ooh.
What are you doing? Oh, you're turning into... Oh.
Yeah,
Those
because
little things.
you could go and form them up by fingers as they go into the breadboard, but
why use the effort? Why not be lazy?
Well, it's not lazy. It's pre-forming them with the pliers, and I have done this many a time.
That's a really good idea to do.
They're not the tidiest of jump wires, I'll give you that, and actually that's because my favourite way with jump wires like this is
to buy them on Amazon.
Yeah, in a box. Pre-cut jumper wire, yes please.
Pre-cut jumper wire.
I don't always get them from Amazon, by the way. I get them from many places.
Oh.
Yeah, in fact, my oldest one, I got them from Maplin when Maplin was still a thing.
Wow.
Yeah.
So you get them from like Pimaroni and stuff.
Pimaroni. Yeah,
Pimaroni.
Pimaroni. I don't know actually. I say Pimaroni, but
I say Pimaroni because like I get everything.
So, it's got a caution here. Always cut the pieces of wire no more than required length, so your supply will last until 24th December. I luckily have supply of wire, but if you don't, you probably want to be careful. Always choose the shortest connection between 2 contacts on the breadboard. So they're sort of worried you don't run out of wire as things get more complicated and you need more wire. Okay, so what do we need for the circuit? Let's get...
Where is the circuit?
So the circuit is here in breadboard form. Okay.
I mean, where's the actual physical circuit?
Where's the physical circuit? We're going to have to make it.
Oh.
Okay, so we've got batteries over here. We'll put them to one side for a sec.
Cool.
Door number 2 was where I stuffed the breadboard.
Cool.
Got a capacitor and LED.
Door number 3 and 4.
And door number 3 I've actually not used for anything, but door number 4 has got the speaker. Cool. So...
there are still pieces of strawberry laces here.
Lovely. Strawberry bootlaces.
I don't think they taste very good.
So what we're going to do, we'll keep the LED in the same place. Now, I've been taking it down so I could fit it back in the box, but actually that might not be the right way to do it. So they've left this button here, but they've not really utilised it. what they have done then, and if you just push on that IC, I was about to say LED or something, I don't know why. Yeah.
There we go.
And clip it right in.
That's not.
And I have no idea if I formed these quite right. So
I mean, I don't think I'd have any idea.
let's push that in there like that.
What's that?
That's just the little jump cable.
Cool. Oh yeah, isn't that the LED with the resistors already in?
That's the LED with the resistor already built in. Yeah, you've been watching me.
Only
Okay,
a little
any
bit.
idea what this is then?
I don't have the name.
Oh, it's a capacitor.
Oh yeah. Sorry,
And now the circuit is showing that the positive side of the capacitor goes down into this pin here, and the negative side, which is indicated by that stripe there, goes the other way. So again, be wary of that with these, because you can blow them up.
Oh, fun. Interesting.
Yeah, they can get quite explosive if you wire them the wrong way. At worst, they just kind of, well, at worst, they kind of burst and, you know, drop horrid sizzling liquid.
Oh.
And that's what they do if they're not too bad, but if you completely overdo it, they go pop.
Apparently, so one of my friends, they kind of like disabled the fans in their computer and then ran as many things as they could until black liquid came out of their computer. And all I can say is, I'm glad you're not using my laptop. Because my laptop already has fan issues, thank you.
Well, there was a time many years ago where I needed to actually get a CPU heatsink off of the CPU.
Oh.
And it was kind of both dried out and congealed, and I needed to heat it up. So at that point, I also did a disable the fan, and I think, and it's probably dated a lot, I ran Prime 95, which...
I have no clue what that is.
Well, it searches for prime numbers and makes the CPU run real hot, which meant the die got nice and hot, which meant I could take it off.
What's a die?
Sorry, the CPU, the CPU chip got really hot, which meant I could actually pull the heatsink off because it heated up and melted the stuff. Okay, so what else have we got? So they're not actually... Oh, I plugged the LED in for no good reason, beyond it was just there before and they didn't bother to unplug it. Lol.
Oh.
Right, however, so what we've got is we've got a thing, kind of an antenna there. We've got our amplifier here. So 2 pins of the amplifier are connected to ground. 1 pin is connected up to what's going to be the voltage rail up here. So they've now started to use the rails for ground and voltage. I was about to say properly, but I guess it depends on your design. This is what's being amplified, and here's your output across a capacitor. And the capacitor here is going to take out, if you've got any what's called a DC, so if there's an offset that's pulling the speaker in one direction, it'll smooth that out, so you get changes through the speaker, not constant voltages, which is good, because if you deflect a speaker for a long time, you can heat up the coils and burn them out.
Oh, don't do that.
Don't do that. No.
That's cool though.
So that's what the capacitor's doing there. It's kind of filtering out any DC. Yeah, and then these switches and LEDs. I mean, I left the buttons in. I took out the LED because I didn't really need it.
Can you press the button?
Yeah, but it won't do anything.
That's
Right.
I thought the button would be connected to the LED.
Well, it would be, but it's not being connected to the LED, because if you look at the output circuit, or sorry, the circuit here, right, this is a positive rail, this is a negative rail, and there's no connection between the positive rail and this button, or the negative rail and there. Oh. Now, with a couple more jumpers, I could do that, but that'd be just fine. Right, and now we need the extra battery that's rolled off, and we put it in. We might even hear a click as the amplifier does its thing.
Click.
Okay. Right.
Just rolled away.
Touch the
What?
So what's happening is there's a teeny tiny signal from you. That's actually me. You can hear that's almost main signal. Now here's where it gets really fun. If I hold this and wave my hand different places. Let's try putting it near something mainsy. My other hand. That's me waving my other
my
hand.
goodness.
And it's going through me. So this is amplifying whatever randomness is on me. Now, the other thing I could do with this is if I touch something that was earthed, do we have anything near that's earthed? It would actually probably make my signal go. Actually, frustratingly, I don't have anything to hand that is earthed. Oh my goodness. No.
We don't have plants or something?
Well, that's me touching just a piece of electronics. That's actually a USB hub with a solid body. So you can hear that quite clearly if I go around the DC thing. Oh!
Oh!
What was that? There we go.
Oh my goodness.
Oh, one of these power supplies is singing. This is me putting my hand near the transformer of a power supply. It's singing. Can't even remember what that's powering. Oh, that's powering one of these lights. Okay, if I unplug it and put my hand next to the unplugged one.
Nothing.
Well, there's still a noise, but it's not squealing.
Wow.
And what about if I put it near the phone?
Kind
of.
How it works?
So, well, basically, whatever signal's going in here, it's making it much more powerful coming out through the speaker. So we're having fun just amplifying whatever our hand's doing. There you go.
It's making a funny noise.
It's making a funny noise depending on where you put your other hand. Here you go. This will even work, I think, if we hold hands.
Alright, wait,
then,
let's show that we're holding hands.
We're holding hands. Hold on. I need a hand a second just to plug this back in so it'll make a noise and make a squeal again. Okay, so you hold my hand.
Oh my goodness.
So we're holding hands and I'm putting my hand near that power adapter, which is singing. And that singing will be the power going through a power transformer, which will be waving, making a... That's literally what it'll be doing. There'll be a waveform going through there, possibly at a much higher rate, unless it's a switching power supply. That won't do a lot. That camera's disconnected. You need to be connected things for it to do anything fun. We're going to try this with me holding Phoebe's hand and her trying to go and touch things. So she's on the same power supply I was. And there's the magic. You can now kind of detect which power supply is making a terrible noise and it's probably adding lots of noise to my lab. I'm willing to bet that that one down there over the other side is going to make the same noise. So if we swap hands,
similar noise.
Yeah.
Oh my goodness.
Different noise. It's actually the same brand for one of the studio lights. That's studio light.
Wait, can I turn it on?
Oh yeah, sure. And that low brrr you can hear, that's probably a mains hum. So it's probably about 50 or 60 hertz.
Oh my goodness.
So you can hear that when I put my hand there.
I don't understand how this works. That's amazing.
It's cool. And all it's doing is it's pushing the sound through the speaker, making the speaker cone vibrate, as I showed in my previous video. Anyway.
I haven't seen that yet.
Nearly a true fan here. We'll work on it.
Ow!
Anyway, I hope you've enjoyed it, and we'll be back for tomorrow's Advent, number 6.
Oh, 6.
Yeah, that was number 5. We're already on number 5. Number 6 is coming soon.
How is it the 6th of December 2021?
Hey, it's all going too quickly. Hope you enjoy it. Go make stuff and be awesome, and we'll see you back here next time.
Bye!